Hello everyone. This is the third part of the same series. We are doing the propositional logic and hardware. We are already done with the propositional statement and the logical statement. In the second part, we covered the questions related to the algebraic method and the truth table method to solve the logical statement. In this, we are going to cover the logical gates. So let us start with the basic logic gates. So a gate is simply an electronic circuit which operates on one or more signals to produce an output signal. Electronic signal is circuit. Electronic circuit is something which will work with 0 and 1 values, and this will operate on one or more signals. You can input one signal or more signals to produce an output value. Now this is based on the three logic gates. We have the inverter. So we have the inverter, we have the OR gate, and we have the AND gate. So in detail, we are going to cover all the three gates one by one. So now first one is the inverter, which is a NOT gate. An inverter is also called a NOT gate because the output is not the same as the input. Obviously, the name itself is actually giving you everything, right? The name is inverter. This is going to invert the value, or it is going to give you the opposite of the value. Okay, so the output is sometimes called the complement of the input. Complement means the reverse of it. So please check it if the input, this NOT gate is working with one input. Please check it if the input is X and the value is low. You know very well low if you will write in a form of 0 and 1. So this low will be 0 and the high will be 1. Then when you will check the bar of it, low will become high and this high will become low. So you can check 0 will be converted into 1 and 1 will be converted into 0. Okay. So inverter gate is quite simple, and this is the way to draw one inverter or the NOT gate. You just have to draw one triangle like this, and then you will give a circle on the this center point of it, and then you have to draw a line. This side, the left hand side, is the number of input or whatever the variable you have taken for the input, that is X here. So X is the input signal. Okay, input signal, and then this is input and it's going here. So this is output, and output is the inverse of it. So this is X bar. So the point is, how are you denoting this one? With the help of bar. Okay, here also you can see, here also. Okay, so this is the first basic gate. The second one is OR gate. OR, okay. The OR gate has two or more input signals but only one output signal. Okay, so here you can see these two are two input signals. Okay, and one is the output. This is output. If any of the input signal is high, the output signal is 1 only. So OR is actually the plus sign. 0 plus 1 will also give you 1. 1 plus 0 will also give you 1. And even 1 plus 1 is also 1. So if any, here the same thing, if any of the input signal is 1, it will give you 1. Please check it properly. The way to write down is same only. If you are not clear how to input the values for the input variables, you can check the first video itself. 0, 0, 1, 1, 0, 1, 0, 1. Then 0 plus 0 will obviously give you 0. At least one signal should be 1. So 0 plus 1. So 0 plus 1 is 1. Okay, F is nothing but, it is actually X plus Y. And this plus is nothing but the OR gate. Okay, so this is 0 plus 1, 1, 1 plus 0, 1, and 1 plus 1 is also 1. Now how can we draw it? You just have to give a curve here and you just have to draw the lines here. So F is the output and two or more inputs. So what you have to remember, at least this OR gate will work with two inputs, right? This is the example for 2, and if 3 are there, then you can draw one more line and it will work with 3 inputs. Next is the AND gate. AND gate is AND, both should be true, okay, and we are denoting with the help of dot. So the AND gate can have two or more two input signals. So this is the at least number of signals, input signals, that should be 2 and produce one output signal. So here the input signals are X and Y. Let me write it down so that you will be clear. Input signals are X and Y in the given example, and the output is what? Output is F. Okay, so input should be at least two variable, at least two variables. Okay, so output is 1 only. So when all the inputs are 1, then it will be high, otherwise low. So if x plus y, so in case if 1 plus 1 is there, it is not plus, okay, it is dot, and dot is generally, if you want to, it is a normal multiplication. So 1 dot 1 will give you 1, and rest if you have 1 dot 0 is 0, and 0 dot 1 is 0, and 0 dot 0 so obviously 0. So 0 dot 0, 0 dot 1 0, 1 dot 0, and then 1 dot 1 is 1. When you will draw it, you will give a straight line here also, and then give a curve here. So these are the two inputs. A and B are given here. Problem A or B. So you can give here also A and B, and the output is F. So this is our AND gate, right? So next to that, when you will check for the more gates, three basic gates are there. Basic gates are AND, OR, and NOT. But more are there. So let us start with NOR gate. Okay. The NOR gate has two or more input signals, but only one output signal. Okay, so this is again going to work at least on two input signal. Here only you can check we have x and y, but only one output signal. If all the inputs are 0, that is low, then the output signal is high, 1. So actually, the values, so you can check obviously 0 0 only will give you 1, and rest for all the values it is what? It is 0 only. How it is working? This is not OR gate, and not NOR gate is actually NOR gate is not plus OR. So first OR plus not. So this is your OR gate, right? And then OR gate 2, and then we are using a NOT gate. So first you please check here in between if you will go for the OR gate. So remember what is that OR gate? Just check it. This is AND gate. OR gate is if any one. OR gate is plus sign, right? If any one. So what any one? I mean if any of the one signal is true, it will give you true result. Now please check it properly. If I will include one more thing here. See, I am drawing one more table. Here I am taking x and y, 0 0 1 1 0 1 0 1. And now you please check x plus y. This is the OR gate. So x plus y I have written. So 0 plus 0 obviously 0, 0 plus 1 1, 1 plus 0 what? 1, and 1 plus 1 is also 1. Now we have NOT here. So NOT, you remember, NOT is going to opposite the value. It is also called negation or complement. So it is the bar. So what it will do? It is just going to reverse the value. So 0 to 1 and 1 to 0, 0 and 0. So this is actually the final output. Okay, so now you please check this is matching. So in between thing is not given, but if you want to properly understand this, then you can understand it in this way also. Well, when you will go for the circuit diagram of the same, you have one OR gate here, and OR plus NOT together is giving you NOR gate. And you can draw it like this also, which is completely fine. Otherwise, the smaller version of this is what it is. OR gate is normal only, and when you are giving a circle here, so this circle is what? This circle is actually the indication for NOT. So NOT plus OR, this is OR only obviously, and with this it will become NOT. So NOT plus OR is NOR gate. Okay, so this is the table. Well, next to this we have the NAND gate, and NAND again the same thing. It is AND plus NOT gate. Okay, you can see we have AND here, and we have what? This is NOT gate, right? So combination, the NAND gate has two or more input signal. Again the same thing we have to remember. It is going to work at least for two input signals, but only one output signal. If all the inputs are high, then the output produced is 0. Okay, then the output produced is 0. Let us check if all the inputs are high. So if all the inputs means this one is 0, and for rest all it is 1 only. So this is fulfilling the table perfect only. Again the same thing. If you want to check the proper explanation, you can go for x here, you can go for y here, 0 0 1 1 0 1 0 1. And now first we will go for AND. AND is x dot y. So both should be true only, 0 0 0 0 0 and 1, right? And then NOT of this. So NOT of this is the final answer. So NOT is, very well, it is going to negate the value. So 0 to 1 and 1 to 0. So 0 to 1, 0 to 1, 0 to 1 and 1 to 0. So here you can see is the final value. Again the same thing, AND and NOT together also you can draw like this in a parallel series. Or what you can do, you can just add a circle here in this AND gate to make it NAND. Okay, so this is our NAND gate. Next we have the XOR gate here. Exclusive OR, we used to call it exclusive OR. The exclusive or XOR gate can also have 2 or more input signals but produces only one output signal. This is same for all. Exclusive OR gate is different from OR gate. OR gate produces output 1 for any input combination having one or more ones, right? But XOR gate produces output 1 for only those input combination that have odd numbers of ones. Odd number of ones. This is the main thing you have to remember in case of or XOR gate. Odd number of ones, right? Let us check. Just check it out here. Odd number of. So here even number of, because 0 and 1. So this is odd number of one time only. Odd values, it is giving you true result. Okay, here also, but this is even, so 0, and this is also no is there, so this will also considered as even. Okay, and the way to draw it, it is also a part of OR gate. So OR gate, you know very well how to draw. This is the OR gate, and just to make it XOR, you just have to give one more line here in the back side. So this will become XOR gate, and XOR is what? Odd number of ones. XOR is odd number of ones. Then we will go for XNOR gate. This is exclusive NOR gate. Okay, so the XNOR gate is logically equivalent to an inverted XOR. Okay, XOR gate followed by the odd number of ones, and this is going to check for even number of ones, because this is the opposite of what? XOR gate. Okay, XOR gate. So XOR is going to work for odd number of ones. Okay, and XNOR is going to work for even number of ones. Please check it if number of ones are even. So for even it will give you 1, and for rest it will give you 0. Okay, so this is just the reverse, and then the table is same only. XNOR OR gate is there, so OR, and you have to draw NOR and XNOR. So NOR gate is how OR also, not of OR. So this is NOR gate, and we are giving a line here to make it XNOR gate. Okay, to make it XNOR gate. Now we can draw a circuit here. So let us start drawing the circuit diagram of the given expression AB plus AC bar plus B bar A bar C. So let us write it down with the proper gates written in between. So we have A dot B plus A dot C bar plus B bar dot A bar dot C. Okay, now again as you are very much clear, like dot is for AND operator and plus is for OR operator. Okay, so replace those dots with AND. So you will write A and B, give it in bracket, plus will be with OR. So OR, we have A and C bar. So you know bar is for what? Bar is for NOT gate, right? So write down here A, and here you will write NOT of C. Okay, then close it, and again plus sign is for OR. Here you have NOT of B. Then you have dot here, so you will write here and then NOT of A, and then then you have C. Okay, and the whole thing you will close it here. So well, this is done. AB plus AC bar plus B bar A bar C. So let us draw this circuit now. So I'll draw it in a second slide. Let me reduce the size. So well, the question is, okay, I have to write down. Then AB plus AC bar plus B bar A bar C. Okay, so well, A dot B, now you understood we have in between the AND gate. Okay, so please draw it properly. You have to draw one AND gate here for these two, A and B. So this is A input and B. Okay, and this is AND gate. Now again you will do it for the second one. It is for A C bar. Okay, so this is A and C bar. So C bar is what? So you will draw one NOT gate here. This side it is C and this side it is B bar. So this is again AND gate. Okay, now we have B bar A bar C. So again you draw it properly. Okay, so you will take B bar. So draw one NOT gate here. This side it is B, this side it is B bar. Then A bar, draw one NOT gate here. This side, left side it is A, and right side it is A bar after NOT. Okay, and because NOT gate, you know, it is going to revert it. And then we have C here. So the direct C input you will give it here. Okay, so then this is also AND gate. When you will check the output of this will give you AB, this is AC bar, and this is B bar, A bar, C. And you have to join all the three parts of this one expression with the help of OR gate. So please take one proper, you can just reduce the size by, combining like this, and then draw one OR gate. So I'm drawing one OR gate here, and finally you are getting this. So this is F, A, B, C, which is also the output. Okay, so this is the circuit diagram of the given expression. Now I have one more expression here, so we can try this one. So now I am not going to write the expanded form. I can tell you verbally it is y dot z. So it is y and z, or x and z. Okay, so total number of variables are 3 only. So let us draw. First we have AND gate only. So draw one AND gate here. Okay, this is AND gate, and you have y and you have z. Okay, so when you will check the output, you will get yz. The same thing exactly is for x and z. This is quite simple question. So you will take the input for x, then you will take the input for z, and when you will go for the AND operation, AND operation will give you, dot here in between, right? So this is yz and then xz. Then again you have to join them together, and with the help of OR operator you will do it. Okay, so draw one OR operator here, and this is the final xyz. Okay, so this is the logic circuit diagram. Yz you are getting with this, because this was AND operator is dot. So in between the input, dot will come. In between the input, dot will come here. The input is x and z, so the output will be after AND gate x dot z, then yz, y dot z, and then we have a plus sign, which is OR operator. OR operator, the symbol for OR operator is this. So you will take the input of these two inside the OR operator, and when you will check the output, you will get yz plus xz. Okay, so I hope you are clear with this. Now we can take one more example, the third one. So here also you have AB and you have BC. Okay, so you have AB, BC and CD here. Yeah, so AB, BC and CD here. So let us draw again. So this is again, you can see we have A. So dot is for AND operator, remember, plus is for OR operator. This is the symbol for AND operator. So you can see 1, 2, 3. So 3 are going to work, 3 dots are there. So we have AND operator, we have one more AND operator, and we have one more AND operator, right? So now let me write it down in the space, in between space. And for this, the input is AB, normal AB. Okay, bar is not there. Then for this it is BC. So BC, and for third one it is CD. So this is C and this is D. So when you will check the output after these all AND gate, this will be AB, this is BC, this is CD, and join them together. Okay, and in between you can see we have a plus sign, which is one OR gate. So you should be clear with what? You should be clear with their, the symbol, and this is the symbol for OR. And when you will check the output, you will get the given expression FABC, AB plus BC plus CD. So I hope you understood this one. So if you have any doubt in this, please don't forget to message in the comment box. And please, if you are clear with everything, don't forget to like, subscribe, and to share it with your friends. Thank you.